about vocab. You know, it's like learning a foreign language. So today's lesson is all about, do you understand my math talk? I've talked really weird language to you for the last 17 classes where I'm talking about rainbows or, you know, that kind of stuff that's not written in any math book. But today I've got to talk vocab, and you've got to learn the vocab. So take your lesson out for today, and we're on lesson 18. It's not a long lesson. And ironically, I'm not going to teach you one new math concept today. So the factoring and the add, subtract, multiply, divide, graphing, everything that we've gone over so far, you're just responsible to know, but you don't have to know any new material today. But you do have to learn the vocab, and the vocab is going to tell you what to do that we've already done in the past. All right, I want you to look up on the screen here, and this is going to help you remember the vocab that I'm talking about today. If you had to go to the store and you had to buy a can of baked beans here for Sunday brunch, and you went to one store, you know, you went to Fry's or Safeway, whatever store you go to, you went to the store and you saw these two cans, and on top of one can was $1, and on top of the exact same identical can, it was $1.25. Which one are you going to pick up to take to the clerk? $1, right? Why? Somebody messed up, do you agree? I always do that. I remember I'm a big gardener, and so I was looking at this garden thing to put in my yard, and it was, I think, a turtle or something that was made out of clay, and it was absolutely gorgeous. I looked at one turtle and it said $30, and I looked at the identical turtle and it said $40. And you know what I did? Because I'm a bold, brassy old lady. I went to the clerk and I said, there's something wrong here. Which price do you want? You can't have two prices. Do you agree? You can't have two prices for the same thing. That's what I'm teaching you today. You can't have two of something for the same thing. Somebody messed up because both cans should say $1 or both cans should say $1.25. When I go to Safeway, they always mess up. You know how they have sales every week, you know, you buy a can of beans and this week it's 3 for $1 or something. And when I go to the checkout, I always check my piece of paper because inevitably, if any of you work at Safeway, I'm sorry, but Safeway doesn't put in the sales into their computers, and so a lot of times I'm paying more than I should, and that makes me mad as an old person. So I go marching up to customer service and say, you made a mistake. That's what today is all about. Today is that you can't have two prices for the same thing. It's against the rules. Now watch. Now I'm going to give you some vocab, so you got to pay attention very carefully. Today we're going to be talking about the word function, and you want to circle that in your notes. What the heck does function mean? Do you know mathematically? Most of you probably don't, because you got to learn this vocab. That's all we're doing today, is you got to know what does function mean. A function is a rule. It's a rule. So what's an example of a rule? When you were a little kid, maybe, you know, under 16 or whatever, your parents gave you a rule and it was called curfew. Does that sound familiar? That was a function. It wasn't a math function, but it was live in my house function. It was a rule, and the rule said you had to be home by 9 o'clock, you had to be home by 10 o'clock, you can't date until you're 16, you can't date until you're 25. I don't know what the rule was, but that's a function in real life. Now I'm going to teach you what a function in math is. A function in math is a rule. You're going to take some input numbers and then you're going to spit out what's called output numbers. That's called the answer. we've been doing functions since the first day of school. When I gave you a math problem and I said multiply this number by 3, tell me what you get, and the math problem said 4 times x, and you put in your 3 and you got 12, the input was the number you put in, the output is the answers on your answer quizzes. Everything you write in your right-hand column on your quiz, look at your quiz that you have to take for today. Everything that's written on that right side is called an output. Everything you're reading in that math problem is called a function or a rule. You have to do something with some number and you better spit out the right answer. You've been doing functions the whole semester. But see, my job is to get you ready for that next level course. And that next level course is called in college algebra. And in college algebra, they deal with functions all the time. Okay, so with functions, you've got what's called an input. That's the numbers you put in. You have to do something. The rule or the math problem is what you got to do, and then your answers are called the output. Easy peasy. Input is what numbers I give you. Then you're going to do some rule to it, and then the output is called your answer. That's on the right-hand side of all your quizzes. You've been giving me outputs all along. Okay, what's a real-life example? Look, let's pretend this is just a piece of wood. That would be the input. Then I'm going to go put it in some machine, and you know what the machine's going to make? A pencil. The input is a piece of wood. The machine, or the rule, says go make this into a nice round piece of wood with some lead inside and an eraser on the edge. And what comes out, the output, is called the pencil. Your whole life is dealing with functions. Your parent gave birth to you. You have some rules while you're growing up, and your output is they hope you turn out to be a pretty good person. You've been dealing with functions your whole life. All right, now, where do you use functions? Raise your hand if you registered to Pima Community College. Come on, everybody. Give me a finger if nothing else, if you're that lazy. Come on. Okay, you're all registered to Pima College. Stand up if you have a very unique email address at Pima.
I think we all do, right?
Thank you, Tim. Everybody needs to be standing up. Go ahead. It gets your brain moving, believe it or not. I used to do a scientific experiment in Illinois, Naperville, Illinois, and we used to have people from the government come and do an experiment. The more you move it, shake your head, stand up, sit down, the better off you are in math. You will remember things. Okay, everyone, stand up. Don't sit down yet. Stand up. Stand up. You look around the room, everybody's got a unique Pima email address. Why? Because if you two are sharing email addresses, legally Pima's going to get in trouble. Do you agree? Because I can't sit there and say, hey, you got an A, you got an F, and have two people get the same email. Do you agree? Okay, now listen carefully before you do it. You may sit down if you have if you don't have a unique A number.
Sit down if you don't.
If you don't. Anybody sitting down? No. Why? Because your A number, what they're going to register you in, like my payroll every 2 weeks, has an A number connected to it, and I don't want you to get my piddle pay from Pima. You can't get my pay from Pima because it goes only to my A number. That's a function. for every person in this room, you are assigned your unique email. You are assigned your unique A letter, A number, right? All right, now sit down. Your first questions for today uses only your eyeballs. You're gonna be shocked when you do your homework this weekend or tonight if you do your homework, because it's real easy. I'm going to give you a picture, and I'm going to say, does this picture show you a function?
Yes.
Why?
Because it gives us one number and that gives us an outcome. But looks like it's subtracted by one. That's the rule.
But I'm not asking what the rule is, I'm saying, is it a function? Does every input, your X is the input, have only one unique output? You see, if I buy 5 cans of beans, it's gonna cost me $4. 7 cans of beans cost me $6. It doesn't have 2 price tags on it. What I'm looking to see if that one input has 2 prices going to it. So the answer for this guy is what? Is it a function?
I'm gonna say yes.
Yes, it is a function, because for every input, there's only one output. Now go to B, and next to B, write yes or no. Is it a function? Look at my table. Here is the X values, and here are the Y values, and tell me if it is a function.
It's not.
Stand up if you think it's a function.
Oh,
It's
If
not.
you think it is a function.
which B?
B. Is B a function?
I sure thought I was.
Yes, you sure thought it was. What are we looking for?
An X and Y, like an input and output.
Okay, I have Mr. 8 goes to the 2.
And 3.
Mr. 8 goes to the 3. He's got 2 A numbers. Can you have 2 A numbers at Pima?
No.
Do you have 2 emails at Pima? No. So what you're looking for is to see if any of the X's have repeats. And repeats going to different prices. If it is, you don't want to go to that store, because if you go to that store, you're going to sit there and say, okay, I'm going to buy this can called 8. I don't know what it is, 8, whatever, beans. One can says $2, and you go, oh, down this list, here's another can of beans, and it's $3. I'd go to the clerk and say, which price do I pay? Somebody messed up. You're looking to see if the outputs have 2 values for the same input. Write that down in your language so you understand it. Now I've given you a picture. I've given you a table. Now I can give you a bunch of lists of inputs and outputs, inputs, outputs, inputs, outputs, inputs, outputs. On your paper, tell me if C is a function. Just write yes or no on your paper.
Yes.
Stand up if you think it's a function.
Okay.
These are all of them. That was theirs.
What happened over here? You guys say no?
Oh, no.
Tim, you say no?
Now I do,
Why?
because of the -1. Well, one of the -1s is next to a 2, and one of the -1s is next to
Oh,
a.
we're doing C.
Oh, we're doing C.
C.
Okay, then the 3.
You know what number 3 is called? The dollar store. Raise your hand if you know what the dollar store is. What do you know about the dollar store?
Everything's a dollar.
It's supposed to be everything in that store is $1. Have you ever gone in the dollar store and seen everything $1? No, that's a ripoff. But it's called the dollar store. This is the dollar store. Everything is $3 though. We call it the $3 store. Everybody should be standing. Because everything in that store is what? $3. That is a function. That's a function. Yes. Because if I want to go, can I borrow this? If I want to go and buy this at this store, I don't even have to say how much is it. They're going to say what? $3. If I go to the store and I say how much is this, what is it? $3. It's not $3 and $4. It's everything in the whole store. If this was a $3 store, everything in the store that you want to take home is going to cost you $3. That is a function. It's not $3, or I don't say, well, for you it's 3, for you it's 4. Everything's $3. So the output can be repeated, but the input cannot be repeated. Like this guy here, the 8 can't go to the 2, and the 8 can't go to the 3 because it's 2 different prices. You don't want to have the right side have different numbers to the same number on the left. Write that down somewhere, yeah.
So the output can be the same,
Yes,
input can.
that's correct.
Must be consistent on either side.
On the right side, your Y values can all be the same,
Not your X.
but your X cannot be
Nope.
the same.
Y must be consistent.
Okay, is D a function?
Yes. No, it's not.
What's making it a bad guy? The neg1 right here is a bad guy. No, the X value, you can write that down, the X value is paired with 2 different Y values, and that makes it a no. This, I'm looking for repeats in the X's, and they have to say the same number. If they say different numbers, I'm confused. What do you want me to pay? Do you want me to pay $2 or $3? That's a bad store when you get the item on the left and you don't know what its price is. Now, all I've gone over with you is vocab, and you're using your eyes to answer the question. I'm not doing any math. I'm looking to see if the left side is paired to only 1 digit on the right side. Watch, this would be a bad one. 5, 7, 11. And then I put a 4 and a 6 here. If the 5 goes to the 4 and a 5 goes to a 6, that's a bad function. It's not a function. Because Mr. 5 is my can of beans, and you're saying to me, well, what should I pay for that number 5? Are you going to pay a 4? Are you going to pay a 6? There's 2 prices. That's bad. That's bad business. But all of these, I could have the 5, the 7, and the 11 could all go to the, let's say, a 6. This could go to 6, this can go to 6, and this is going to 6, and that'd be called the $6 store. Everything in the store is $6, but there's no ifs, ands, or buts. I'm not trying to rip you off and charge one person $6 and one person $5. Put the quiz away. All right, so you have to be careful that you understand what a function is. You got it? So the first slide, it is just visual. Now let's go to the second slide. You're going to be asked on your homework, is this a function? And what you need to know is that the X value is called the input, and the y-axis is called your output. Now, what you're going to do is called the vertical line test. You want to visualize doing a whole bunch of vertical lines and see if your vertical line that you're going to draw will only cross the aqua line once. It's called the vertical line test. That means it is a function, because for every x, look, every x, there's only one y ordered pair. Now, what's not a function, if I take this same shape and turn it sideways, again, the x is the inputs and the y value is the output. Do you see the two red dots? That means that at negative, whatever this is, neg 3, we have two values for neg 3, and you can't. Okay, is that a function? All you gotta do is find one vertical line that gives you two dots on the aqua shape, and you say, nope, it's not a function. Now, you know what, whoever's got the music on, turn it down, please. All right, now, you know what you guys are going to do in Math 151 and 142, whatever class you're gonna go to? You're gonna have shapes like this. That's a function, because for every vertical line I draw, it hits the shape only once. That's the kind of shapes you're going to be studying in your 151 class. In my class, we're going to do real simple ones. Okay, let's go to the next one. Is this your next one? Yes? You're going, when am I ever going to use this in my life? Everything in your life is almost a function. If you have some kind of rule or some kind of, walking into a store, that's a function. Here's an example of what's a function. You go to the gas station to fill your car with gas. If you get 0 gallons, your cost is $0. If you go to the gas station and say, give me 1 gallon of gas. Well, you can tell this is a little outdated, right? What's 1 gallon gonna cost me?
$3.50.
$3.50. Now, if I go to the gas station and I ask for a gallon of gas and they fill it and they say $3.50, if you go to the gas station and you say, I want a gallon of gas, and they say, oh, you gotta pay $10, would you be pissed if you just heard that I got the same gallon for $3.50? You'd be mad, right? I'd be mad. I'd go, what the heck? That person got it for cheaper. I want that price. It means it's not a function. It's not good business when a person has to pay different prices for the same thing. The output is what the cost is. So 2 gallons is $7, 3 gallons is $10.50. This is called a function. The input is how many gallons you're going to buy. The output is how much you pay. The rule is that every gallon is $3.50. Okay, so if I ask you what's the input, or I could say what's the domain, those mean the same thing. Input and domain mean the same thing. I'm looking at the X part of ordered pairs. I told you, today is all about vocab. You better be taking really good notes. Don't just look at me. If I'm writing something down, you should be writing it down too. Your output or your range is the Y part of any ordered pair. Okay, so is this a function? when I say, is it a function, you look at your x's and see, did you repeat any? And are they going to different prices? Nope, didn't repeat any, so it is a function. Now I'm going to give you pictures on your homework. This is an upside down V. And I'm going to give you the picture and I'm going to say, what's the domain and what's the range of this picture? When they ask for the domain or the input, they are looking at your x-axis and they're saying, what numbers are in that picture? Well, you go, well, there's x is 0, x is 1, x is 2, x is 3, x is 4. But what do those arrows on the end mean?
There's infinite.
It's going to keep going to 5, to 6, to 7, to 8, but I just got tired or I ran out of room. So paying attention to these arrows is really important. So my domain or my input is neg infinity to positive infinity. In other words, it's the numbers 0 to whenever you get tired of counting. That V is going to keep getting wider and wider and wider at the bottom, but I ran out of space. So I use those arrows to tell you it's going to keep going on forever. Okay, what's my range? The range, look, I look at the Y, and my range starts at what? 4. And then the arrows say it's going to keep going down and down and down. What's my range? 4 to negative infinity. It starts right here at 4. This is my range. It's starting at 4. And it's going down because over here it's going to be maybe x is 10, y is negative 10.
Why isn't x 4? Why is y 4?
Because this is where the shape
Oh, that's why.
starts. Yeah.
Because that's why.
We're talking about my range. So if the figure started here, and this is, here's 0, here's 1, 2, 3, 4, what would be the range?
Negative infinity to 1.
Uh-huh. So if this is y is 1, and my shape starts here, it's 1, y is 1, so it's going down, so it'd be negative infinity. If my figure went this way, it would be 1 to positive infinity. All right, what shapes are we going to do in my class? You're not going to have funky shapes. What's this called, the pink line?
Linear function.
Linear function. We did this the very first exam. But now today I'm going to say to you, what is the domain of this shape? When I ask you for the domain, look,
It's the input.
you want to put this in your notes. When I ask you for the domain, you're looking to see what parts of the x-axis are covered in your pink shape. Well, if I didn't have the arrows there, you'd say 5 to neg 5. But because the arrows are there, it means that line's going to keep stretching on and on for what? Ever. Both in the positive direction and in the negative direction. So your domain is going to be all real numbers, or you could say neg infinity to positive infinity. Write that down. Now, what's the range of this shape? Well, the range, again, comes from looking at the y's. So, oh, I got a y here, I got a y here, a y here. What do the arrows mean again? What do the arrows mean? goes on and on forever. So the y is going to be all real numbers also. So every line that you drew that's a diagonal line, if I ask you what's the domain, what's the range, you just say -infinity to positive infinity. Every graph you did for me that's a diagonal has a domain and a range of -infinity to positive infinity. It's the easiest question I'm going to ask you. No work. You have to understand that that line goes on and on, both in the x and y direction forever and ever. All right. Do you understand what a function is? Do you understand what domain and range are? Domain are the numbers you put in. Range are what comes out, or the price. You got to do some rule. Like I could say to you, I'm going to be your parent. I'm going to be your parent, yours, every one of your parents. And the rule is you
Well, that's
got to be
nice.
home by 10 o'clock every night. So I could go through and say, Tim, what time do you have to be home?
10.
What time do you have to be home? Huh?
Yeah.
Come on, help me.
10.
10.
10.
10.
10.
Okay, that's a function. Each person is assigned a time to come home. I didn't say to Tim, what time do you have to be home? Now, you did it to me. I didn't say to Tim, what time do you have to be home? And he goes, oh, 10, maybe 11, maybe 12. You did it to me. You made it not a function. Because he said never, and then I said, follow my rule. And he said, okay, 10.
Reinforce the function.
Yes. Reinforce the rule. You're grounded because you didn't come home at the right time. Your whole life's been a function, whether you know it or not. When the government said, when can you start driving? Everybody was going to be 16. That's a function. The rule is you can't drive when you're 15, and you can drive when you're 16, you can drive when you're 72. Interestingly, when I took out my stroke, 3 weeks ago, they took my driver's license away from me. That's why I couldn't come to class. I said, I have to come to class. I said, no, not until you go through physical therapy. So I had to go through and prove to them that I could walk a straight line. And then I had to do stupid little exercises for the gas pedal and for the brake to see if my brain was affected. Now, some of you might say, I think my brain was affected. But they said no, so I was able to drive again very quickly. But the bottom line is there was a rule, and I had to abide by the rule. That's what you guys have to do. Your input is a number, you're going to be given a rule, and then your output is the answer. All right, now you got to learn function talk. This is real important. Do you see the P next to the X? You guys are really used to thinking that's a multiplication problem. Do you agree? P times X? Or you could sit there and say, well, maybe it's half of an ordered pair, or maybe it's inequalities. Boy, we've gone through a lot of stuff. When you have a capital letter next to a baby letter that's in parentheses, that's your clue that we're now talking what's called the F talk, function. It's called function talk. And we read this like this. So on your paper, draw a line. We read this as the P of X. Think of the letter P as defining the rule. So if I tell you, you've got to be home by 10 o'clock, I could call that the curfew rule. Do you agree? But instead of using the word curfew, I'm going to call that the C rule. And so I can say the C of Tim, the C of you, the C of you, the C of you, and I'm going to say, what time do you have to be home? And so instead of saying the word curfew, I'm just going to abbreviate it with the letter C. Is that okay? Yeah, you'll understand it, right? So this one says, I'm going to make up some rule for you, and I'm going to call it the P rule. And what's inside is always your input letter. On the right-hand side is called the rule. Write that down. So we read this as the P of X equals 4X. When I read it that way, I understand that this is a rule called the P rule. And the input is going to be the letter X, and then whatever number you give me, what do I have to do with that X? Multiply it by 4. Now when you get the answer, that's called the output. All right, so the P of X, the value of the P of X is called your output, and this is called the rule. Now let me show you what your math problems are going to look like. They're easy. They're going to give you this. Look. The f of x equals 3x plus 4. That's how we read that.
I always wondered why people say that.
F of x equals 3x plus 14. So what does the f stand for? That's just your function name. Could have been the g of x, could have been the q of x, could be the b of x, could be whatever your last name beginning letter is. They just make up a letter. And that's naming your function rule. The input value is always what's inside the parenthesis. That's the numbers you're going to go look for, the x numbers. And the output, you're going to have to multiply that number by 3 and add 14. So today's computation, we're back to 3rd grade math. Use your calculator or your brain, I don't care. So what's your math problem going to look like? Look over here. Everybody look up here. It's real important. You see how I give you one function rule here? What's that function letter name? F. How about the green one over here? What's that function letter name? G. So if I say go look at the F function, are you going to go look at the green stuff? No. You got to go look at the yellow stuff, if I call the F function. If I say go look at the G function, you got to look over at the green stuff. So, what does your math problem look like? It's going to look like this. It's a bunch of stuff, and you got to make sure you remember what I'm asking. I'm going to give you this top line, and then your math problem is going to look like this. Give me the f of 3. Give me the f of -1, and you're going to go, what the heck is that? Well, again, inside the parenthesis is the number I want you to put into the rule that's called the F rule. I can't put it in the G rule, I got to go to the F rule. So if I want f of 3, look at the work that's on your paper. Do you see how I put it into the rule? Now you pick up your calculator or use your brain, whichever works faster, and you give me the answer as what? 15. If I ask you for the f of -1, you got to put -1 in for the x, multiply it by 4, add 3, you get -1. So what I'm asking for is my input is 3. Tell me what the output number is when you apply this rule up here that's the F rule. Now if I ask for the G rule of -2.4, I want you to do this math problem. You just write it down and then pick up your calculator or your brain, if it works that well, and you'll get 10.56. It's not hard, it's computation. All you got to do is this computation problem, and you got a calculator to do it, but the math problems look like this, and they're not color-coded. So you have to make sure that this letter out in front matches the letter out in front of the rule that they're going to give you. Easy peasy? It's computation. Okay, next slide. Let's get a little bit harder with functions. What's a linear function look like? Look. What does the f of x mean? F is the what? Name. X are the numbers you get to put in, and what's the rule? M times x plus b. Have we already done mx plus b?
Yes.
M is the slope, b is the y-intercept. Do you remember that? So this is what we did in week 6. We're now in week 18, or class 18, not week. Class 18. In week 6, I gave you this. And now in week 18, or class 18, I'm going to give you the same math problem, but I'm going to use math 151 terminology at you. And you're going to look at it and go, oh, do I multiply f times x? If you're not in class, that's what they're going to do. They're going to think you have to multiply those two together. It's not. The f is the name of the function. F is used a lot for function names, and x is used as the input value. And so I'm saying the rule is whatever number I give you for x, multiply it by 2 and add 3. Now, the most basic linear function is the f of x equals x. Have we done that one already? Yeah, when I gave you this. Do you remember this one? And I said graph y equals 3. You guys remember that? Y equals 3. Where are all the y's equal to 3? Right here. Y is 3. All of those points are where y is 3. I'm going to ask you to graph it again. But I'm going to give you this math problem instead of that one. But you're going to do exactly what you did up here. If I said y is 10, you draw a horizontal line at y is 10. If I give you y equals -4, there's y equals -4. Is there any work to do? No? An identity is just drawing a horizontal line crossing the y-axis and at whatever number I give you. Yeah,
So when we see fx equals x.
f of x
f of
equals x.
Is x, it would be the same as y equals x.
Yes, y equals a number. Okay, if it's not an equation like this, but if I give you f of x equals x, then if x is 1, or if x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. There is an example of an equation that's an identity function. In other words, the x and the y points are exactly the same. 0, 0, 1, 1, 2, 2, 3, 3. All of these points on this line here is called an identity, because whatever you put in for x, the y is going to match it. It's an identity, like looking at a mirror. This guy is called a constant because it's a horizontal line and all the y values are going to be a 3, a -5, a 6, whatever.
If you had a line that was straight up and down, I think.
That's not a function.
Right, I remember
Excellent.
why now.
Yep, that is not
No
a
pun
function
intended.
because x is 0, x is 1, x is 2. This is the cans that have multiple prices on it. Vertical lines are crap. Garbage. They're not a function. Because on a vertical line, you're saying this costs $3, the same thing over here is $4, $5, $6. It's got different prices on it. Vertical lines are bad, not a function. Horizontal lines are the dollar store. Horizontal, x is 0, y is 4. X is 1, can of corn is still 4. Can of beans, $4. A shirt, $4. Pair of pants, $4. a hat, $4. Everything in the store is $4, but if you go buy it and your friend next to you wants to buy the same thing, the price is the same for each of you, everybody's going to pay $4. That's a good store. But if you walk into the store and you say, oh, the beans is $4, then in the next aisle, the same beans are $3, the next aisle, they're $2, everybody would go into the cheaper aisle, wouldn't you? You'd never pay full, the big price on it. So vertical lines are bad, horizontal lines are good. Okay. They're gonna ask you to graph a linear functions. Look what it looks like. Have you seen this before? Look. Down here. This is what it looked like before. Y-intercept is 5. And then you have a -2 slope, down 2/3. Remember that? The only difference today with your homework, I'm going to give you one that looks like this, and I'm going to say graph, but it's not going to say y equals, it's going to say f of x equals. And again, if you're not here, you're going to sit there and say, I have to multiply f times x. I don't know what they're doing. It's just naming the rule. This is called the rule f. And every letter, every number from the x-axis you put in, I want you to multiply it by -2/3 and add 5. It's going to turn out to be a linear equation. If I say graph this, again, this is just read as the f of x equals -6. Every point has to be a -6. That's a horizontal line. If it says f of x equals 8, you're going to put a horizontal line at 8. That's a good function. That's called the $8 store. This is called the -6 store. Okay, the last slide. They're going to give you a math problem, one of these two, and they're going to give you a picture, and you have to go find the other piece. What am I talking about? They're either going to give you the input or the output. And you have to give the other matching part. They're going to give you the x and you have to name the y. They're going to give you the y and you have to name the x. So watch. This says find the f of -3. Don't multiply f times -3. We're now dealing with higher level math, and we're talking about functions, and functions always names the rule with the plain letters, and then it gives you a parenthesis. If there's just an x in there, you don't do anything. Well, you will in 151, they're gonna make you do some weird stuff. But what you're gonna do is you're gonna say f is -3. So this is the x value right here inside the parenthesis. So I come over to my chart here, and here is your x, this is your y. So I go to the x and I find -3. There's -3. Do you agree? But I'm looking for what's the point on the pink line that crosses that -3. So do you see how I go and I go, oh, the pink line isn't here. Oh, it's way up here. So what is this point right here? It's -3, comma, what?
5.
5. So the answer to this one is 5. So I'm asking you, when I give you the number inside the parenthesis, you're telling me the price. So you have to go and find on the chart where -3 and that pink line are going to cross. Now if I reverse it and I say, okay, find the f of x when the rule, some rule's been done, and the answer is -2, tell me what number I put in. What item did I buy at the store? You go, oh, well, when they write it this way, they're giving you the y value. So I want y to be -2. Well, here's where y is -2, but I have to go find the pink shape, and now tell me what x's value is. 4. It's using your eyes, not your brain, for your homework today. You gotta understand how I'm giving you the math problem and what you have to do to find that answer. So, here is your quiz for today, or for Monday. Tell me whether this linear expression, it should have arrows on both ends, is that a function?
Yes.
Yeah, it's a diagonal line. Any diagonal line, you say yes. What's the domain?
Infinity, infinity.
Yeah,
All real
negative
number,
infinity to positive infinity. What's the range?
all real numbers.
All real numbers are negative infinity to positive infinity. Have I done any work?
I thought the
No.
range was output.
It's called output. Range
So-
and output is the same, input and domain is
But the
same.
choices are still infinite, I guess.
Yes. Good question.
So, it's not what the person actually outputs, in like the work shown, okay. Sorry.
You okay?
Yep.
Okay. Second one, do you know how to do this? F of x equals, and here is my rule. Do you see that rule? Last night you had to factor it. Tonight you don't have to factor it, because I'm teaching you your next level course vocabulary. And the next level course vocabulary says we don't multiply f times x. F is the name of the function. X is the value, is the variable in your rule, whatever it is. And now this is telling you what number I want you to put in, and then use your calculator to get the answer. So you're gonna have to put in -2 times -3 squared, then subtract 4 times -3, and then you're gonna have to subtract 10. And you're gonna use your calculator and just plug that all in, press enter, and it should give you the right answer if you've done your keystroking correct. This is the easiest lesson of the whole semester, because there's no algebra I'm teaching you, it's all vocab and how do you do it. Look at number 3. Is this relation a function? What are you looking for?
You're looking for the input. Or
Yeah, you look at your inputs, and you can't have the same can of beans listed. Or in math class, it's the same number listed going to different numbers. So what's the bad guy in this math problem?
a domain of 2.
The 2. This guy here is bad. Why? Because my 2 can of beans is gonna be costing me -$9, or it could cost me -$2. Well, which one is it, buddy? You put wrong labels on the cans. So we say no, and then you have to tell me why, and you have to say because you have 1 input going to 2 outputs. Is this a function?
Yes.
Yeah, this is almost the Y story. I can have B be costing Y dollars. I can have C be costing Y dollars. That's your dollar store. Everything in the store is $1. That's good. Nobody's gonna get mad at me if I'm a clerk if I say everything that's in this room is $1. And then number 5, graph it. Last problem, graph it. Well, again, when you graph this one, what do you have to do? Well, week 6, I gave it to you this way. What's your y-intercept? All together. Where's it crossing the y-axis?
-6.
-6. And what's the slope?
1/5.
Don't you remember me doing the stairs? You gotta lift up first, then we walk across, right? So what's my slope?
1/5.
1/5, so you gotta go up 1 over 5, draw your line, bam, we're done. Tell me how much work you had on that quiz. It's using your eyes and understanding the vocab. It's the easiest quiz to get an A on, but you gotta either, make sure you have your practice quiz out now and write yourself some notes. What's the domain and range of any diagonal line? Neg infinity to what? Neg infinity to positive infinity. So the domain is negative infinity to positive infinity. The range is negative infinity to positive infinity. No work. It's gotta come from up here in the brain or using your notes when you take that quiz. I'm done. You got 20 minutes to work on your quiz for today.